Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So I will continue from the previous video. Okay, so there were many types of bridges in this world. Okay, arch bridges, beam, cantilever, truss, cable stay, and also the suspension. So let us go through one by one. Okay, the first type of bridges is arch bridges. Okay, there is arch shape, okay, below the superstructure. All right, from my reading, the arch above the superstructure is not considered as the arch bridges. Okay, because the arch bridges have their own concept. All right. Okay, so you can see here that this is the load, okay, from the superstructure, the dead load, the life load. All right, and all of the forces are transmitted through the arch to the surrounding earth. Okay, so all the forces are go through the arch. All right, and the most important stone in the arch is the keystone. All right, so the arch bridges have abutment at each end. All right, see, this is the abutment, whether it is a natural from the mountain, from maybe a wall. Okay, and then it can be supported by the concrete, and the weight of the bridge is thrust into the abutment at either side. So means that this abutment will produce and also contribute to the stability of the structure, and the compressive forces created by the load are transferred down through the arch and resisted by the support or abutment as it bends. Okay, so the force distribution is the compression side at the superstructure side. Okay, and then go here, go to the arch, and then the arch will distribute to the abutment. So this abutment will contribute to the stability. Okay, if you are talking about the arch, okay, this is like the construction is like the use of stone to produce an arch. Okay, but in reality, the arch can be made by RC, okay, reinforced concrete, and also can be made by the steel. Okay, based on the shape, okay, the arch shape is having a maximum stability, which is the strongest shape, because if we have one element for this arch, okay, let's say this arch is made from reinforced concrete, so that there is no point of failure. Okay, compared if we have the rectangular, triangle, so means that the edge of the shape, okay, let's say rectangular, okay, there is 4 shape. Okay, so every edge, okay, 4 edges, okay, every edges need to be connect. So the connection point is the point of failure. So that's why the advantages of these arch bridges is it is very strong and can be built from a wide range of materials. But the disadvantage is limited span unless multiple arches are used, and uneconomical use of material. And other thing is the buildability of the arch is very, very difficult. Alright, unless we're gonna use the maybe precast, okay, which is already casting at the factory. Okay, this is some kind of arch bridges. Okay, this like aqueduct in for Roman. Okay, this is maybe they use for train, or else can be the roadway. Okay, this is Japanese and Chinese, I think, like this. Okay, all the traditional building, they have their traditional bridge like this. This is just a pedestrian bridge. Okay, second thing is beam or girder bridge. Okay, this is a very simple bridge. Okay, we just need a pier. Okay, it's like simply supported. and then we have the beam or girder. Okay, the most basic type of bridge, the girder bridge or beam bridge. Okay, so this typical consists of a beam simply supported, alright, and each side by a support end can be made continuous later. Okay, so in terms of forces, the upper part will have the compression and the lower part will have the tension. Okay, so the tension and compression will stabilize each other. Okay, and then support by the pier. Okay, currently most of the beam bridge are precast. Okay, for not so many time need if you use precast or prefabricated item. Alright, in case of RC and PC reinforced concrete. Alright, and most of them are simply supported, and some are made continuous on site. Okay, based on condition. Okay, we have simply supported, we have cantilever, and we have also the continuous. But if we need a longer beam bridge, maybe we will use the continuous one. But of course, we need to construct it simply supported and plus simply supported, and then plus simply supported, and then it becomes the continuous. So this kind of beam bridges in the world, okay, for train, okay, for roadway, okay, and basically this type of bridge will consider very big of forces and loads. Alright, so that's why it just consider the structural element that can resist the load. Okay, no excessive design such as the aesthetic or any others. And the third one is truss bridge. Okay, truss bridge are straight. Okay, trusses are comprised of many small beams that together can support a large amount of weight and span great distance. Okay, typical span is 40 to 500 meter. Okay, so this, we can say that the truss bridge is also strong. Okay, so depends on it also contribute to the aesthetic, and based on my experience, I've been participated in the national bridge model competition before, and based from our experiment, if we have a deflection, okay, in our bridge, and the most suitable element that we can enhance to the bridge is trusses. It will help to minimize the deflection. And this is type of truss bridge that we have. This is the Harbour Bridge in Sydney. Okay, this is a bridge, truss bridge in, if I'm not mistaken, in Scotland, if I'm not mistaken. Alright, this also contribute to the aesthetic. And this is the K-truss bridges. Another thing is suspension bridge. Okay, suspension bridge needs to have very strong main cables. Okay, cables are anchored at the abutment, okay, so that it will give the stability to the bridge itself. Okay, so the load is distributed. Okay, the load is distributed to the cables, to the pier, to the beam, and all components are interrelated. Okay, such as the London Tower Bridge in United Kingdom. Okay, suspension bridge, and this is the most popular bridge. Okay, Golden Bridge in San Francisco, and I'm not sure where is the bridge. And for this two bridge is like a pedestrian bridge. Okay, no need to resist the load from vehicles. Okay, another thing is cable stayed bridge. Okay, all the forces are transferred from the deck through the cables to the pylon, and roadway deck can be concrete box, steel box, and steel truss deck. This is also one of the common and one of the popular type of bridges. In Malaysia also we have this type of bridges. Okay, we have in Putrajaya. Okay, we have in Penang Bridge. Okay, and this is pedestrian bridge in Singapore. And this is, you know what's the name of this bridge? This, we call this as Jambatan Bangkok. Okay, this is the proposed bridge connecting between the Johor Bahru and also Singapore, right? So the type of bridges is considering these reasons. Okay, the span length, the bridge length, the beam spacing, material availability. Okay, like in Malaysia, we have concrete in a huge amount, but we don't have the steel, not in a big scale. So that's why we prefer to use the reinforced concrete. Okay, even KLCC foundation also we use RC. Okay, site condition. Okay, the foundation, the height, the pace constraint, the speed of construction. Okay, we have to target. We want to put it in a 1 year or 2 year or maybe 10 years, 20 years. Okay, so these all contribute to the considering of which type of bridge you want to build, and the aesthetic, of course, the cost, and also the access for maintenance. Okay, so an ugly bridge, however safe, serviceable, and inexpensive, is not a good bridge, because usually we're gonna build a bridge with aesthetic. Okay, like in Tokyo, we have a cable suspension bridge, very famous. I'm not remember the name, in Odaiba, Tokyo, or let's say in San Francisco, Golden Bridge. Okay, now in Malaysia we have the new bridge. Okay, the drawbridge in Terengganu. Okay, we have open gate bridge in UK. Okay, so it's contribute to the landmark of a country. Okay, long span bridge over a river can be a landmark, thus aesthetic should be an important factor. Okay, at the same time. Okay, but the most thing that we need to cover is about the function of the bridges. Okay, the bridge should blend with the environment. Okay, the most transition between members and determinant of bridges appearance in order of importance. Okay, so the aesthetic of bridges is very important. Okay, for the external appearance, internal view, sequential view, and beauty and stability, bridge and environment integration, material choice, and moderate of lighting. Okay, it can be an aesthetic things as a landmark, and also to attract the tourists. Okay, because like London, okay, we come to London, okay, just because of the open gate bridges, right? Okay, so it can be a good aesthetic value to the country. Okay, so okay, another important factor is also about the cost. Okay, no discussion of design consideration can be conducted realistically without asking how much is it going to cost. Okay, this is the first thing that the owner or the client of the project can need to ask. Okay, because no money, no talk, right? And constructability. Okay, we have the arch. Okay, the arch is very strong, but the ability and constructability is very difficult, and no discussion of aesthetic is complete without considering the constructability. So the aesthetic will come from the architect, and our task, okay, in construction, okay, we need to think about the constructability and the buildability. Alright, so we will continue this lecture after this. Okay, please do the assessment. Alright, assignment is choose one bridge and detail out the superstructure, the substructure, the foundation of the bridge, and submit through the Padlet link given before 10 p.m. 22 November 2020. Alright, okay guys, stay safe everybody. Assalamualaikum, see you.